The fourth problem from last bi-weekly contest, find the maximum number of fruits collected. They're given a game dungeon of size n cross n, and we are asked, or we are given three children at position top left, top right, and bottom left, and all of them needs to reach the bottom right corner, and that is the destination. So if I draw it out, if this is the grid, this is n cross n grid, by the way. It's not, it doesn't look like it, but it is. So if I have n cross n grid, right? One, two, three, four, 1, 2, 3, 4. So I have one children which can move this direction, this direction, this direction. One children here which can move this direction, this direction, this direction, and last children here, it can move this direction, and this direction. All right, and all of them has n minus 1 moves, right? And all of them needs to reach this particular destination, and every cell has certain number of fruits. We want to maximize the number of fruits. If also there is scenarios where all children or some children might collide in a cell, then only one of them will get the fruit, the other one won't. So after getting the fruit, the value in that cell will be 0, right? So since every child has n minus 1 moves, let me call this child A, B, and C. So here, since child A has only n minus 1 moves, and it needs to mandatorily reach in those n minus 1 moves to the destination. So there is only one route that kid A can take, that is diagonal route. Since the diagonal route will take n minus 1 steps, so it can never divert from its diagonal route. This is the only route it can take, right? So if I draw a line, so this is the diagonal, right? So child C and child B can cover regions which are above and below the diagonal, right? Since it can move only, in terms of moving up, it can only move in a, what should I say, in the direction of top right, right? So it can only go till this point. Beyond this, if it goes, then it won't be able to reach to its destination no matter what he does, because it can not move down, right? So it can move, if this child C reaches here, then it can move here, but it can't move down. It can move right, but there is no space, so it can never reach the destination. So in that case, this kid C can never cross the main diagonal, right? And the same thing goes for kid B. It can never cross the uh, main diagonal. It will always remain on the top side of the main diagonal, right? So we can use DP, we can use bottom of DP, and only maximize the area for this particular area for kid C, and this particular area for kid B. I know it's a little messy, but you get the idea. Let's remove it, draw a clean diagram. Let's have 5 cells. Alright, and since you are going to use bottom up approach, then we can look. Let me also create a diagonal. Right, this is the diagonal. We have kid A, B, and C. Since A is only going to take this route, let's not draw that. We need to maximize it for kid B and C. So if the kid is here, right? If kid B or the C, the kid and the bottom left is here, then it must have, taken, it can go only in these directions, right? This one, and this one. So this point, it must have reached from here, here, or here, right? If there was a cell here, it must have reached in these three directions, from these three directions only. So I can just take the maximum from these three and use it here and add the fruits that is present in this particular cell. So that will be my answer for this particular uh, cell. And I can do the same thing for all the rows or all the cells below this particular main diagonal, and the same thing goes for this particular uh, kit as well. So let's determine the formula. So reaching at this point from the same row, so I comma from the previous column, j minus 1 will be one direction. This one will be nothing but I'm moving forward, so I'm checking for the previous column, so it will be j minus 1 again, but the row is also previous, so it is I minus 1, j minus 1, and the third one is this one, so it's from the next column but previous column, next row but previous column, so I plus 1, comma, j minus 1. The maximum of these values plus the current fruit of I comma j will be my answer for this particular cell. Same thing goes for this one. Suppose the kid is here, from here, suppose the kid is here. Then it must have come from, it can go from here, here, here. So it must have come from here, or here, or here, right? So this particular area is previous row, previous column. I minus 1, j minus 1. This one is same row, same column, previous row. I minus 1, j. This one is previous row, next column. Previous row, next column. So among these, the maximum plus the fruit, I comma j. Alright, so this is how we are going to solve this problem. For the diagonal, will calculate it initially. So let me write the formula so that I don't have to check it from there. Formula. The first thing is calculate or sum up the main diagonal. Formula will be for the bottom left child, dp of I j is equal to fruits of I j plus dp of I comma j minus 1, dp of I comma j minus 1 plus dp of I minus 1 j minus 1 and I plus 1 j minus 1, I minus 1 j minus 1 and I plus 1 j minus 1. Similarly for sorry the top right child, it will be similar, but since it's previous row, previous column, same column, next column, right? Let me make this also very symmetric. Previous row, same row, next row, alright? And the column is already always j minus 1, and here the column of the row is always previous. Actually, I think I did something wrong. This should be I minus 1. Cool. So let's code it up. So first we need to uh, sum the fruits of the sum of the fruits of the diagonal. So let's have diagonal is equal to 0 initially. Let's have n fruits dot size. For the diagonals, I am just going to go from 0 till n, and diagonal plus equal to fruits of I comma I. So that will give me the diagonal fruits. So for maximizing the upper top right child, I'm going to go from this position, since from here, from this particular point, I'm already going to uh, include it inside the initial dp array itself. So dp of 0 comma n minus 1 will be this fruits of 0 comma n minus 1, right? So the remaining positions which I need to maximize is from j being 0 or j being 1 to n minus 1, and I going from n minus 1 till this point where j is greater than I, right? So j should be greater than I. 0, 1, 2, 3, right? Suppose this is the cell that represents 3 comma 1, right? Sorry, it represents 1 comma 3. So j is greater than I represents the values or the cells which are above the main diagonal, right? So let's have a dp. A 2D dp is needed for the bottom of the approach. Each will be of size n plus 1. Initial value can be probably minus 1. So I must be, or yeah, I must go from 1. So this is I, it's going from 1 till n minus 1. So 1 till I less than n, j is going from n minus 1 till j is greater than I, j minus minus. Alright, now since this is for the top right child, I'm going to use this value. So let's have a max value from the three cells previous to this, which will be nothing but this, right? Since there are three inside the max function, let's put curly braces. At this point, if max value is not equal to -1, that means it is updated and it's good to use that value. So dp of ij will be fruits of ij, which is the fruits for this particular cell itself, plus dp of or plus max value, right? Let's not forget to initialize dp of 0 n minus 1 with fruits 0 n minus 1. Okay, so this is going to iterate. Let's remove few. Okay, so this is going to iterate for this particular child from here till here. Even this won't be included. Why? Because this is I is equal to j, and I is greater than, sorry, j is greater than I is the limit. So it's never going to reach this point as well. It's only going to populate this value. So I'm going to have to populate this value as well forcefully, right? So I'm going to use this particular cell since dp has n plus 1 values. I'm going to use this particular cell and this particular cell for populating this particular cell outside of the loop forcefully, right? So dp of n minus 1, or let me create a I is equal to n minus 1 comma j is equal to n minus 1. I j is equal to fruits of uh, let's not take the fruits because I'm already taking it inside the diagonal. So let's not take it one more time. Let's only take the maximum of these three values again. That's it. Similar thing for the bottom left child. Let's create a TP1. Here it will be n minus 1, 0, n minus 1, 0. This will go from the loop, the jth or the column will go from 0 till n minus 1, actually till n minus 1 here, but since the row is going to go from n minus 1 till I is greater than j, right? So I is greater than j represents the things below the main diagonal, like this is greater than, I is greater than j, I is greater than j, I is greater than j, right? So it's going to have a loop for the jth column from j is equal to 1 till j less than n, and I from n minus 1 till I greater than j and I minus minus, right? And this time the max will be these values with braces, let's not forget, and these things will remain same. This will be updated, and finally I can just return diagonals plus dp. By the way, these should be dp1, 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 dp of n minus 1, n minus 1 plus dp of dp1 of n minus 1, n minus 1. Alright, let's see if this works. Let's not have a redefinition. Okay, this works. The time complexity will be O of n, right? And the space complexity will be, I mean, not O of n, but O of n square. Space complexity and time complexity will also be O of n square, right? That's the fourth problem. Thanks.